Next on stage, we have Robin Gupta, who will be presenting on boundaries of multi-agent systems. Here you are, Robin.
Hello, hello everybody. First and foremost, there is no problem with the mic and the audio system. I am having a bad throat today. Okay, I'll still try to keep it fun and simple and light. If you have questions, catch me outside. If I'm not able to answer it, I'll message the answer back to you. Don't worry. Okay. One thing to remember is that at the end of the presentation, I will ask a question. Before you guys ask me any questions, and generally, when I go to community conferences, I'll give out a copy of the book which I had authored, signed by the author, to the person who answers that question correctly. As simple as that, right? That question will be from the presentation. So that also ensures that you don't sleep after a good lunch. You actually try to stay attentive for the book and the photo with the author and all. Okay. We'll get going. I have been given some strict timelines, so we'll try to stick to it. Okay, there's some issue.
The folks are not here because lightning talks are going on. I take that as bad estimate. But
Okay.
if you want to do an interactive session till then, it's hardly 5 minutes.
Yeah.
That'd be great.
Here then what I'll do is I actually skip to one slide
Yeah.
where there is an audience interaction. Okay. So okay. Don't bother about all this. See, this is one thing which I wanted to, gauge from the audience today. Scan this Slido QR code. There is a very simple question. Where are you in your agent maturity? Right? Uh, I have prototyped agents. That is the first answer. Built and tested agents but not deployed to production is the second answer. Built and tested agents and deployed to production, third answer. Handled large scale multi agentic systems for executing million tasks per month is the fourth answer. We can't see your names, so feel free to pick the right answer as per your state. Also, like, this is not the question which will get you the book anyway, so. Okay. So I see three people have answered on the top right of the screen. There are 17 people in the room. I'm good at counting. So there are 14, 11 people who have not answered. See, also this question helps me ground the presentation for you guys. If you've only prototyped agents, right, then I will try explaining those parts better. If you guys are like already doing billion transactions per month, I'll like skip slides and jump into code more directly, right? So that is why that question. Okay, so many people have prototyped agents. Built and tested agents is the next, but not deployed to prod. Okay, okay, five more people. Browser testing, for API testing, for accessibility testing, for visual validations, and such. And then each of those agents have their own very specific tools. Browser agent, as the name suggests, will have browser as a tool. API agent, as the name suggests, will have REST as a tool. Accessibility agent, as the name suggests, will have Axe core as a tool. Have people heard about Axe core or what is Axe over here? Not much. Okay, just for context, so a lot of countries, very recently Europe also enabled it, but in the US there's something called 508 compliance. Every website should be accessible to people with low vision, right? And to test such websites, there is a library called the Axe core. So it's AXE and then core. So they will do the testing as long as you feed the website's code to it. So our accessibility agent uses the Axe core as the tool for doing that testing. Okay. Everybody with me so far, right? I think I'm not going too fast, right? Okay. So on the screen, what we've achieved with our open source testing agent is that anybody, technical, non-technical, product manager, BA, designer, can write a simple English language test case like the one written over here. No code, no locator, no Selenium, no playwright. You can just say, given I'm logged into so and so account, and I navigate to a certain page, and I click on the new button, and I enter the account name, billing street, click on the save button, then the toast message for successful account creation should be displayed. So we give this to our multi-agentic system. It will plan out all the steps and then run them for you. So while this does not look like very magical, let me see if I can find a magical example for you guys. Yeah, you can even do something like this. So you can use the same kind of English language tests for testing an e-commerce website, wherein you can say, given a user is on the URL as this, when the user clicks on search icon and on the search bar user enters text as something, and the user filters access as a size filter, then only one product should be displayed. See, while this is fairly detailed, if you guys want to experiment it, I'll share the QR code and everything. You can also write one-liner test cases. You can just say, go to Wrangler, add a double XL black jacket to the cart, and then try to perform the checkout. Even that one-liner test case will be executed by our agent, and that is the power of multi-agentic systems. But as I said, showing is the key. So to run this, I would just have to run this one command with my own OpenAI key. It's all open source. And once you run it, it will open the browser, try to log into Salesforce, which is one of the most complicated UI systems out there, and then try to do the testing as per these steps, which is going to account section, clicking on the new button, and then entering account name and other details, and then trying to click save. While it is doing it on its own, like no hands, I'm not doing it, the agent is doing it. Any questions so far so that we can answer them upfront? Yeah, please. Yeah, over here. Oh shit. Okay. As things happen, demos will have these things. Yeah, right. Yeah. So it is asking, I think, two-factor auth because the Salesforce org which I was touching is not whitelisted with this place's IP address. Okay. So it is blocking me. So we will kill that guy. Okay. Back to Sir's question over here. See, this is all open source. To manage that, you can have secrets as part of a CI/CD, and then you can call that and inject that at runtime. You can do stupid stuff like me, wherein I have a simple file for demos called test data, right? Um, or one second. So you can either just put up everything in text over here, or you can also put it as part of the CI/CD and then inject it at runtime, right? That is like the preferable approach. Have it like an environment variable or something. Yeah. Okay. Any other questions so far? Yeah, please. Yeah. No, see, very interestingly, the multi-agentic system has its own agents which run on top of LLMs. LLMs, interestingly, already know about those things. So, what our agent will do, as I will show you guys in a minute, is it will actually create a plan on its own and then try to execute that plan. So, if it hits one of those roadblocks, it will actually try to figure out the new step at that point, create a new plan, try to heal itself, and then move forward. Yeah. Okay. So, I think, again, the whole point is um, showing, not telling. So if I search for plan, so this is one of the agents in our multi-agentic system. It's called the planner agent. I'll show you the system prompt also for it. It's like a fairly large system prompt. But to search question over here, our planner agent will first take the input test case that you've written, create like a comprehensive plan out of it, and then give it to its child systems. So that is where initially we actually faced boundaries to this point that if we had a single agent system, that wouldn't create a proper plan, that would misbehave with the execution. Then we created multi-agentic systems. Then we realized that if every agent creates the plan, then it's like everybody in the team is behaving like a tech lead, which is not the right way to go about it. So then we cut out that responsibility as well, and then we had a planner agent at the top whose only task is to create a proper plan based on the input test case. Okay, so that is one way in which we overcame that boundary of a multi-agent system not behaving properly. But once the planner agent has done its thing, So then we have something called as the browser nav agent. Yeah. So the browser nav agent is actually having browser as a tool. It will open the browser. It uses Playwright as a system to actually automate that browser and go through the execution. And then the browser nav agent takes the plan from the planner agent and starts executing those steps. Similarly, if there is, let's say, an API step to be invoked, then that API agent will stand up and pick up that task and start running it, right? What we realized at that point is that the communication between these agents was not happening properly. Again, thanks to multi-agentic systems and their boundaries. So then AG2 has this interesting concept of a chat manager. So think of the chat manager as the project manager on your team. What a project manager does is they will take information from point A, enrich it, and then give it to point B. Project managers generally don't execute something on their own. They act as the communication conduit between different team members, right? So that is the other way in which we overcame the boundary of this multi-agentic system where the communication was not happening properly. To fine tune it, we actually added a chat manager who acts as the coordinator between all these different agents that we have. Okay. Actually showing that diagram that I had on my screen earlier. Okay. So this is our GitHub repo. If you go to or if you try searching for TestZeus AI Hercules, you'll find us. I think 36,000 plus installs so far and a growing community of 200 plus members. I'm trying to find that one diagram which I was showing earlier for the architecture of the system. Yeah, this guy. Okay. So when you give in the test case, it goes to the planner and the assert agent, which breaks that test case into its like atomic units. Then that is fed to these multiple agents that we have, a browser agent, an API agent, a security agent, an SQL agent, or even a timekeeper agent. See, in a lot of test cases, you could have that wait for this one thing to happen. So then we realized that the browser agent was very crappy at it. So we added another agent, the timekeeper agent, whose only task was that whatever timekeeping instructions coming through, it keeps the time, blocks the execution, or makes the other people wait for it, and then proceeds, right? Then these agents will have some sensing mechanisms. For example, when the browser agent has to interact with the browser and look at the UI, let's say a submit button on the screen, then the browser agent will keep on sensing the UI and figure out that, okay, where is the submit button? Or has the HTML of that submit button changed now? For which it will generate a new plan and then go on executing the click of that submit button. There are some helper tools and then there are some action tools. So Playwright is the action tool which the browser agent has for actually performing the click. So we didn't reinvent the wheel over there. And similarly, Nuclei is something we use for security and Axcore is something we use for accessibility. Very interestingly, the LLMs could be your self-hosted, self-managed, or you can also use APIs from OpenAI. We've also introduced the concept of long-term and short-term memory in the system so that the agents don't lose track when large test cases are being executed. So that is another boundary that we faced when we were designing multi-agentic systems, is that there's something called as the context rot. What happens is that with so much chat happening and so much actions happening, the context going back to the planner agent or to that one single agent becomes pretty huge. So then we started dividing that into memories that can be actually cut it out into a short-term memory or a long-term memory, right? And all of these then go talk to the application under test is the idea. Okay. That being said, we use supervisor agent for implementing all of this. And okay, I think we are doing fine time wise. Yeah. Okay. So now all of us know the boundaries and how to solve them. We devised the world's first open source testing agent last year. A brief about Hercules, as you guys can see over here. And while we are on this screen, one thing which I also wanted to show you guys was the system prompt for some of these agents. So here we are looking at the high level planner agent. Okay. Just try reading through a few lines of this. Okay. Is this visible at the back? No, maybe. Okay. So for example, the planner agent must ensure that each next step must directly continue from the step after previous step execution. So very interestingly, like it's a pretty long file, but each of these came from some of our failures. When we realized that the planner agent was not able to create the right plans, is when we added another bullet point, and then we added another bullet point. Lo and behold, 1 year later, we have 200 bullet points as a system prompt for this planner agent. But then, very interestingly, if you go to the agents direct, you will also find other agents sitting over there or sleeping maybe, wherein it has some of the core rules. So, for example, we specifically highlight what the task boundaries for the browser agent, because if we don't say execute only web navigation tasks, as you guys would have seen with agentic systems, they behave like a dog. You give them something, they will do that thing, then they will do five other things. After a while, you have some dog poop on the ground, right? So that is why we had to constrain the responsibility, saying that you are a browser nav agent, you will only do browser things. You will not do API things that somebody else will do, right? Um, it will also analyze all the page elements, input fields, buttons, so on and so forth, and only execute one function tool at a time. As you guys would have seen with recent agentic systems like Claude Code, they are very, again, like a dog. They are very eager to get your love and affection. They will try to keep on doing multiple tool calls, multiple executions in order to horrendously fail at their task outcome. So then we told our agent to be very specific to one thing and one thing only, and only one function or tool at a time. It must be persistent is something we found, because it would give up. And then also we added things like, if you need clarification, please ask. Don't be that over happy dog. Okay. So those are some of the system prompts which you guys can look at. And if you feel some of this is still crappy, please feel free to raise a PR. More than happy to merge it back to the master. But very quickly going through this directory structure, you will find that okay, you will find that we have agents in one place. So as I was telling, there are agents for API, navigation, browser, planner, MCP, multimodality, security, SQLs, and timekeeping. And then each of those guys get some tools as well, so which can be found over here. So for example, there's a small captcha solver tool which we don't shout about, because captchas are supposed to stop bots, but we built a tool to bypass that. But that being said, we have other interesting tools as well on this. So for example, getting the URL, hovering, or even MCP tools. And then what we realized after a while was that we need some extra tools which are in the inventory. For example, drag and drop was a complicated UI interaction. So we built a different tool for it, and there's an instruction on the browser nav agent that if you run out of options on your tools, go in the inventory and check for some extra tools and see if you can do that task. So that is one thing we realize, is that as a boundary of a multi-agentic system, agents can actually run out of tools, just like how humans run out of tools. We will have pens and papers and pencils, but exactly one night before exam, we will need a ruler. So then we will go and buy a ruler in the night. So for that, we created the extra tools repository. So feel free to explore it, guys. You can find it on TestZeus Hercules or even on our homepage. Going back to the presentation. So that is what we launched last year. And see, this is the one thing, just if you had to take away one thing from this presentation, this is that slide. Just imagine what would you achieve if you had 100 people at your command, right? See, human society's progress is not limited by money or wealth or availability of resources. Human society's progress is limited by the availability of smart humans, not humans, smart humans, right? The whole idea is that if each of you, I think 30, 40 people in this room had 100 agents at your command, we are suddenly as a group commanding an army of 30,000 or so agents plus humans. So very interestingly, here are just some of those use cases which you guys can explore. Sales example was one which I was giving earlier. You can have a lead management agent which automatically categorizes through one agent, scores and assigns lead to the right sales rep using another agent. Service is another one. Very interestingly, when I was reading a recent report, sales and service are the two most commonly used areas where multi-agentic AI systems are deployed. So service, you can have an agent or a multi-agent system for order and refund processing. Marketing is sentiment analysis. So very recently, I came across this project called the Society of Minds. So when, let's say, me as a marketeer has to launch a content, I would imagine scenarios about my audience, just like how I was doing at the beginning of this presentation. But what if your audience could be simulated by AI agents and you can launch an experiment campaign against your target persona of AI agents and see how they react back to it? So that is one use case. And then there is e-commerce agent. So today when you go to an Amazon, you will get the same prices for everything for everybody. But very interestingly, each of us behave differently for different pricing strategies. So, what if you could have a small army of agents which enables highly personalized dynamic pricing for the users? That's about it. Scan the QR, do leave us a star. Thanks. That's about it. Thank you, guys. There is one question which I think I was supposed to ask. Okay, everybody ready? Yeah, okay. Then first I'll ask question. Then you guys will ask question. Yeah, okay. So in the presentation, right, there is one pattern which we followed for building our multi-agentic systems. What was that pattern? So how do we give the prize now? Okay. Shit, okay. Another question then. As part of the presentation, which we just saw, can somebody name all the testing capabilities which our agent does? Tough question. Like raise hand first. Yeah, okay, here. Yeah. Okay, good. Right answer. Okay, I have your book. We'll give it after the session. Now, questions to me, please. Yeah, I think one here and one here.
Uh, yeah. How did you do evals?
Oh, shit. No, I'm just kidding. See, for example, if you go back to the library, right, you will find the most painful thing which we had to build out was something called the tests. Okay. So we built out tests for some of those responsibilities, you know. So, for example, we had something for the future tests or test features, right? And then, for example, we actually wrote test cases for each of those capabilities. So there's an expected result and then there's some test data. And here, let's say we are testing the Zerodha website for accessibility. And, it should not be any issues on that page. Interestingly, on this page, there are many accessibility issues. So that is part of the expected results. So we actually wrote tests for each of these capabilities. We run them pretty often and then we run them as part of builds as well. But that's our like baby way of doing evals for this. Exactly. But see, interestingly, evals came as a fashionable term for LLMs. When you think about that task complexity and autonomy, when we want to do evals for agents, that is a much longer running task and much more complicated and sophisticated. If I had to test my own agent, there is no point like creating one data row for it. The whole point is, can this system as a whole, with the planner agent and the accessibility agent and these three other agents, actually do that one accessibility testing feature which we gave it? So that is our definition of the evals, like not the standard scientific term, but that is how we came about it. Yeah. Okay. Yeah. Okay. Screw mic. Yeah. Correct. Oh shit. Yeah. We do have that. So what you can do is over here, if I go here, then there's a certain file called the agents config. Okay, this is an example one. Obviously, we won't put up our own OpenAI keys over here, but you can actually say that for example, the nav agent should use this like Mistral model with this capability and this one thing. So you can actually have different agents for and with different LLMs. Just extending that point, what we found was that the planner agent with a thinking model behaves much better, but then at the cost of time, right? So, but yeah, we do have that capability. Yeah. Yeah. Check. Yeah. Yeah. See, interestingly, in our system, when we face that, right, first, we've not solved it 100%, to be very transparent, right? I think even OpenAI is struggling with like context as a problem, right? That being said, our planner agent actually takes care of a lot of those things. Because we've cut out the context management part to one agent, the other agents can do their thing properly. So the browser nav agent is not bothered about maintaining the entire context and then referring it for each and everything. The planner agent is actually responsible for it. But that is one of the ways in which we've tried to manage it. Memory is something which we were trying to play with. We realized that we can do that, but then again at the cost of time. Every time you cut out the context, put it to a text file, and then you add it back and then send it somewhere, just adds 3 4 seconds. And then, as all of us would agree, interestingly, LLM APIs are actually slow. Like, I'm actually bothered about why is OpenAI API so slow, right? Every time that call has to be made, it just adds 5 10 seconds to the execution. So we've tried to do it locally more than remotely. Yeah. Okay.
How do you exchange data between the multiple agents? So if you have structured data, large structured data,
Yeah.
how do you exchange that between agents?
I think there are multiple things at play over there. So one is that the chat manager is to some parts responsible for that. The chat manager actually manages the whole chat context and passes relevant pieces between them. If one of our agents has questions, they can actually go back and ask to the planner agent also and get the answer. So that is other way.
And let's say the planner agent assigns some task, and in response to the task, it expects some data out of that agent, of the sub agent. How does the sub agent determine what data to share, and how does it share that data?
Okay, I'll give two answers. One is the happy answer and one is the true answer. Okay. So the happy answer is that we do something called as a state management, wherein what data needs to be given to the next agent is actually slotted in a short-term memory and then passed on. But here is the true answer. That see, working with agents, what we realize is that most of the things with agents are like a coin flip. That day, that agent is having a bad day. So you will have a bad day. It will eat up the damn data. Then the next agent will go and roam around in the park. There is one big submit button on the screen, like in your face. You can see it. Your friends can see it. But the dang browser agent can't see it that day because that data was lost somewhere. So that is the true answer. I think everybody is struggling with those things. We're still trying to solve some of them.
And let's say in your test case, you have jargons, enterprise specific jargons.
Yeah.
How would your agent understand them and use them within its context?
I think that's a very solid question. See, interestingly, all of our agents are built on top of LLMs. So the quality of LLMs actually defines how much context it already has. Let's say in Salesforce, I think many people in the room will not know what is an app launcher. App launcher is actually a small UI button on the Salesforce screen. But since the agents know what is Salesforce and what is app launcher, it can still understand some of those things. In the paid product, which I should not be talking about, we have something called as memory management. You can upload videos and files and everything, which is used as the context for these agents to execute the test case. But that is all again in the closer. See, yeah, yeah. I think my co-founder is actually smarter than me, so he actually did have something hidden. See, if you want to do that, right, the easiest way would be to put it up in the memory parts. Very interestingly, our agent is extendable with MCPs and such. So you can build your own small drag, like baby rack solution, or you can even connect it to an MCP using the open source product. So the whole idea is that, again, we as a company strongly believe in open source for hackers, tinkerers, Python audience. You can, who can and you can try it out, do it on your own. If you don't, you want to be lazy like me, again, closed source is the answer. Yeah. Okay. Cool. Awesome. Thank you so much, guys. It was a pleasure. All the best. Can we click a selfie with the audience if it is okay? If you are okay. Yeah.